in the midst of learning about the measure of center of the mean, it's fun and also really meaningful to talk about the mean absolute deviation, also known as MAD. While the mean reflects the average of a data set, the values within a data set can vary significantly. One way to analyze this variability is to look at how the data values deviate, meaning how they differ, from the mean value. The mean absolute deviation of a data set is the sum of the distance of all the values from the mean value divided by the number of values. Okay? Keep in mind, and this is really important, that distance can never be a negative value. Hence the term absolute deviation, which is very similar to another concept you're very comfortable with, absolute value. So what does this MAD value tell me? Well, let's look at the following survey results. Now in this survey, someone was asking how many members are in your family. These are the results on a dot plot from survey A. These are the results on a dot plot from survey B. You can see that there are 10 data points here. 3 of them said there are 3 total people in my family. 4 of them said there are 4 total people in my family. And 3 of them said there are 5 total people in my family. This dot plot shows that our data is very close together, clustered quite a bit. And you can clearly see that the middle of that data is 4 people in a family. However, the results of survey B are quite different. You can see that 4 people answered that there were 2 total people in their family. 1 person answered 3, 2 people answered 5, 2 people answered 6, and 1 person answered there are 7 people in my family. So the mean absolute deviation is going to tell you how that data is spread out with relation to the mean value, which is a measure of center. Here you can see the data is more spread out, and the middle is not as clear as it is here. So the MAD is really going to help us understand what's exactly going on. So how do I find the mean absolute deviation? Well, let's find the mean of all of these data points first. I'm going to add 3 plus 3 plus 3, plus 4 plus 4 plus 4 plus 4 plus 5 plus 5 plus 5. And that sum of all of those data points is 40. There are 10 data points, so I will divide by 10 to find the mean of my data. 40 divided by 10 is, in fact, 4. So the mean of this survey is 4. Okay? Over here, I would add 2 plus 2 plus 2 plus 2 plus 3 plus 5 plus 5 plus 6 plus 6 plus 7. The sum of all of this data is also 40. And when I divide by the number of data points, 10, I get that the mean is 4. Very interesting. The mean for this survey is located right here, which is obvious, right? But the mean of this survey is here, which may not have been as obvious, but let's look at this dot plot for a second. 4 is pretty much in the middle. You've got 5 data points up here and 5 data points down here. 4 is a little bit closer to the 2, and my guess is because 4 people answered 2, in order for our balance point of the mean to be accurate, 4 does kind of make sense. But we may not have been able to guess it so quickly, like we could have right here. Now, we have simply only found the mean. The mean is not the mean absolute deviation. The mean is just what you have to find first. Now we're going to find all 10 distances from the mean. So I'm going to look at every single data point, and I'm going to write down the positive distance that each of those data values is from the mean, and in this case, how far each of them are away from 4. So 3 is only 1 away from 4. So it's 1, 1, and 1, because 3 people answered 3. Now 4 people answered 4. Well, how far away from 4 is 4? It's not. So the distance is 0. And I've got 0, 0, 0, and 0. And then 5 is 1 space away from 4, and that occurs 3 times. So 1, 1, and 1. Now I find the sum of all of my distances. 1 plus 1 plus 1 plus 4 zeros plus 1 plus 1 plus 1 is 6. So I have 6 is the sum of the distances from my mean, and then I divide by 10 because there are 10 of them. So 6 divided by 10 is 6/10, or 0.6, which is still 6/10. Okay, now, same thing over here. The mean is 4, and I'm going to find the distances that each data point is, or the distance that each data point is away from 4. So 2 is 2 spaces away from 4, and that occurs 4 times. So 2, 2, 2, and 2. I've got 1, 3, and that's 1 away from 4. There's nothing at 4, so then I have 5. Well, 5 is 1 space away from 4, and that happens twice. 6 is 2 spaces away from 4, and that happens twice. And then I have 7, which is 3 spaces away from 4, and that occurs once. Now I find the sum of all of these data points, 2 plus 2 plus 2 plus 2 plus 1 plus 1 plus 1 plus 2 plus 2 plus 3. The sum is 18, and I divide by 10. So I'm finding the average, the mean of the distances from the mean. So the mean, absolute deviation from the mean. And that is 18 divided by 10, which is 1 8/10. Notice, this data is more clustered. The MAD is smaller. This data is more spread out. The MAD is larger. A small mean absolute deviation value means that your data is more clustered. And on average, each data point is relatively close to the mean value. A larger mean absolute deviation means that your data is more spread out. And on average, each data point is farther away from the mean value. In our last example, a mean absolute deviation of 6/10 reflects exactly what we expected, a more clustered set of data values. Whereas a mean absolute deviation of 1.8, 1 8/10, which was more spread out on the dot plot. So, let's try it on our own. Let's try to find the mean absolute deviation of a couple of data sets. I've written the steps here for you. The first thing you need to do is find the mean. Then you need to find the absolute deviation for each point, meaning the distance that each of these are from the mean that we haven't found yet. Then you find the mean of the absolute deviations. So once we have all of those differences, we find the mean of those. And then that's our mean absolute deviation. Okay? Well, let's try it. So I've got 2, 3, 3, 4, 5, 7, 8, 8. So I'm going to find the sum, and I'm going to try to do this as quickly as possible. That's 16. This is 12. I've got 6 and 4 is 10 and 2. So this is 22, and then 22 and 16 is 38. So I've got 40. A sum of 40 divided by 1, 2, 3, 4, 5, 6, 7, 8. 40 divided by 8 is 5. This number right here is my mean. So now I need to find the absolute deviations from 5, which means how far away from 5 each of these data are. So from 2 to 5 is a distance of 3. From 3 to 5 is 2, and there are 2 of them. And then I've got a distance of 1, a distance of 0, a distance of 2, a distance of 3, and a distance of 3. These are my absolute deviations, my distances from the mean. Now I need to find the mean of these, and that will be my MAD. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 is the sum of the absolute deviations, and I divide by how many there are, which is 8, and my MAD is 2. My work isn't very beautiful, but you get the picture. Okay? Now, let's compare these 8 data points, and then we're going to kind of talk about which set of data is more spread out based on the mean absolute deviation we get. So I'm going to find the mean first. This is 15, this is 13, and this is 12. So that's 25, 30, 40. Again, How lucky are we to make that work out? 6, 7. Yeah, it's beautiful. Okay, so 40, again, divided by 8. The mean, again, is 5. So let's find the absolute deviations, the distances each data point is away, or are away from 5. So I've got 3 4s, so that's 1, 1, 1, 3, 5, 0, 0, 0. Can you see where this is going? We've got 1 away from 6 and then 2 away from 7. The sum of these absolute deviations, 3, 4, 5, 6, is 6 divided by 8. Well, 6 divided by 8 is 6/8, or 3/4, or 75/100. So you tell me, which set of data is more clustered, closer together? It's really, you can observe it very well. You can already tell that these are closer together and more clustered around 5 than perhaps this set of data. Now this set of data may be clustered compared to something that goes from 0 to 30 with 5 as the mean. That would be really intense, but still, okay? So the MAD here is less than 1. The MAD here is 2. So obviously when I compare the two, this is more spread out than this one. And I know that because the mean absolute deviation is larger.